Hello and welcome to yet another interesting conversation. I'm Alex Bolboaca coming to you from Mozaic Works studios, and today my guest is somebody who has been through and got a degree of a real engineering degree, let's say, not software engineering, but who is also a very fervent advocate and coach on continuous delivery, continuous deployment. It will be very interesting to have a conversation about what these things mean and how engineering compares to software engineering and a few other things around these ideas. So welcome, Thierry de Pauw.
Hello, thank you.
Before we start, it would be interesting for our audience to learn more about you. I know that you are a speaker, you are a coach, but you also have a degree in, as I said, in engineering. Can you tell a bit more about yourself? So how you started with computers, why did you go to engineering, and how you end up with doing continuous delivery coaching?
All right, that's gonna be a long story. So so actually I've studied electromechanical engineering. So it's the heavy machinery, like factories production. And I've did a minor in there about production management. So how do you optimize production of systems? I've always been interested by computers from back in the days of the XT computer, the 8086 or something. And I was in fact destined to actually study computer science until someone said, yeah, it's a lot of statistics. And then I was like, oh, no way, no way I'm going to do this. And so I went for the electromechanical engineering. I've actually worked 2 years in there as an electromechanical engineer together with developing software for managing production of a small business that produced keyboards. And then I did the switch to software. And how did I got into continuous delivery? A bit by accident. It's like somewhere 2012, 2011, I was asked to coach a team to improve the engineering skills. And the team was responsible for something like 15 applications with 6 people. So, well, first thing we did was introduce continuous integration. And then we've set up the Jenkins, and then you move on and you start like, yeah, but if we have to install all these applications manually, it won't work. So you start by scripting the deployments. We've added automated acceptance tests also, and well, all of a sudden we had continuous delivery in place, and the book came out at the same moment or around there, and we started reading the book, and we were like, oh, actually we did the right thing, and that triggered something to me, because well, what I've understood from all of this was that quality is actually very important to achieve that. And I've always been a person who put a lot of focus on quality, but no one cared about that. So every time I've suggested, well, you better write this thing like this or like that because of this and this. Well, nobody cared. And then now all of a sudden everyone wants continuous delivery. I was like, yay, let's work on quality. And so I've just changed my focus and positioned myself like, yeah, I'm going to help you achieve continuous integration and then continuous delivery. And that worked.
All right, so to go back a little bit, you came from engineering into first a bit of working as an engineer, and then you switched to software. And after a few years, perhaps you can make a bit of a comparison between what we understand as software engineer and what is going on in engineering. And to give you a start, I have a theory. Since I'm trained as a software engineer, I don't know a lot about the other side of engineering, but I have a theory that at least in other parts of engineering, you are bound to be more careful, because a bridge will fall down unless you go through certain steps and so on.
Yeah, that's the idea. That's especially the idea that software engineers have when speaking about engineering, but then they are actually speaking about civil engineers, people that are building bridges and buildings, and they create nice drawings about these things, and we think we need to do the same. I was more, so I've never designed, well, yes, I've designed machines, but it was more in an iterative way that we designed machines, because, well, me and my colleague, who had 10 years more experience than me, he was really like my mentor. We actually designed the machines for the company we worked, because there was no machines available on the market, so we had to make them ourselves, and it was a lot of trial and error. We also wrote the software for these machines, and we just tried things, and then we moved on. And as we learned, we moved further on, and etc. etc. So it wasn't that idea of, yeah, it has to be strict and analyzed and planned, and no. And I remember when I came then into software, and they came with those heavy requirements documents and those very detailed analyses, I really felt stupid, like, yeah, no, I would never think of all of these things when starting to implement this. I would just start with the simplest thing and then build on top of that. At the time, when I thought that, well, nobody was like thinking the same around me, it's only, well, like 10 years later that I actually discovered that I wasn't the only one thinking like that.
So you found that designing physical machines is closer to an iterative way of work.
Yeah.
And in some ways, software is perhaps even better fit for that, I imagine, because it's easier to change software, at least in theory.
It's just easier. Well, refactoring a machine is slightly more difficult than refactoring software.
Yeah. I have the same, I reached the same conclusion after doing some research. I was starting to write on a book on software engineering, which that we canceled because it was too much work, actually. And it would take me about a few years to write it as I wanted to. And the publisher didn't want to go through that. And but one thing that I did as a research was to figure out that actually a lot of engineering is basically iterative. You start from something and you experiment, you try out, you see, does it work, does it not work, is it closer to what we're trying to achieve or not, and then you kind of go with the flow. So is that, that's roughly correct. And another thing that I see is that many people confuse, I think, engineering with kind of science, which is
so engineering is actually not an exact science. In fact, it's an applied science. We use science to do practical stuff. And I remember I loved the applied mathematics, for instance, because it was like, so this is the theory. Now this is too complicated for us. Let's simplify. And that was the part I loved. Like, okay, we remove this, and now we have a nice formula that fits in our heads and that we can apply.
Yeah. I remember the same actually. I think it was one of my first lectures in in the Polytechnics University, where we started with a very long formula, and then it was like, this is less than 10%. Doesn't matter. Cut it down. Yeah. So it's funny to me. The way I thought about it, and I'm bouncing some ideas to you because I think it's an interesting topic. The way I thought about it is that engineering is more like we are trying to build something. We need to make it work. We don't necessarily need to make a full theory of how it works in the general context. It just needs to work for our particular context.
Yeah, it's a bit like that, yeah.
And science tries to, yeah.
So you don't try to think about all the possible use cases or possible, well, if this happens, what do we need, and blah blah blah. So, yeah. Start simple and then you build on top of it.
And for these physical devices, is there the same problem with things like errors, malfunctions, unexpected things? Because in software, it seems that a lot of code is dedicated to actually treating errors rather than the happy part.
Yeah, well, in our case, no, it's a long time ago. So we're speaking 18 years ago. I guess we handled that with software, which is pretty easy. Yeah.
Okay. All right.
And some of the things were also manual, so we didn't try to automate everything. So there was always a person next to the machine, which can handle the exceptions.
Yeah, that makes sense. That's true. Perhaps in my
so you have to see this. It's only 2 people building machines for a company of 50 people. So.
Yes. And another myth is probably about planning and estimation. That in software we don't estimate properly.
I really don't remember we estimated things, really. We didn't do that. It was like, yeah, we went with the flow and it was going to be ready when it's ready.
So,
yeah.
No estimates.
No.
Okay.
No, I didn't work in very big-sized companies that worked with projects and that kind of stuff. So I haven't. So I guess they do have that in bigger organizations, and especially in more consulting, so engineering consulting organization where they have project management, and I guess they have the same problems as we do regarding estimates and well, not achieving the target as expected, because well, shit happens.
And last question about this topic: do you know Mythbusters, the show?
Mythbusters. It rings a bell.
Yeah, it's a discovery show with where they kind of build stuff to bust myths, various myths.
Okay, yeah.
Yeah, and to me that was one of the shows that I think is closest to engineering, to what it really is, because they keep building these weird machines to simulate various contexts and cars crashing in a certain way or things like that, and then it's funny to see the process actually how it goes. Okay. So let's move on from this to, let's say, what you're doing mostly these days, I imagine, which is around continuous delivery. And the first thing that I think would be useful, I know it's been a long time since we used these terms, but I feel there's still a confusion between continuous integration, continuous deployment, and continuous delivery.
Oh yeah.
Can you make some light on this?
So yeah, continuous integration is really the practice of integrating code into mainline. And mainline is your line of development that acts as a reference from where builds are created. So the purpose of this continuous integration is that all the code that everyone in the team produces actually integrates with each other. And you want to do this continuously because you want to know this continuously. And ideally, you can just pick the latest build that comes that you've produced, and you can just drop that in production, and everything continues to work. Continuous delivery is extending this to having like a deployment pipeline, which is a pattern where you visualize all the steps that you have to do to take code out of version control and to get it into the hands of the users, and deploy it in production and release to users. And you try to automate all those steps. But you can start with well, having manual steps and then automated steps. And as you move on, you can then start automating more and more and more. Now, the purpose of continuous delivery is actually continuously delivering an artifact. So you don't need to actually deploy continuously into production. Just producing continuously an artifact, but that you know that this artifact is actually good, and that you can take it and put it into production, and that it went through all the tests that are needed. Ideally, you also have all your configuration that is handled by this, and all your infrastructure code is also handled by this. And then continuous deployment is that you are continuously deploying to production, so that every commit in version control ends up automatically into production if it went successfully through all stages of your deployment pipeline.
This clarifies it. I hope for the audience. I'm sure some people will forget it soon, but it's still a good thing to recap these things. And now, so you've seen a number of teams, I imagine quite a lot of teams who were struggling with these ideas. And what would be interesting, we are trying to focus on common challenges that we find in organizations and in teams, and some ideas on how to fix those. And I imagine that you've also seen a lot of challenges like that. And I can throw some of you. So one challenge is when you have a lot of existing code. You know, you're coming with this idea of let's start to do continuous delivery, at least, if not deployment. How do you do this then if you have like 1 million lines of code in C++?
Yeah. I've actually had that. I've actually helped an organization in C++. I knew at that time shit of C++, and I remember I said to them, look, I can help you. And if you explain me the C++, I'll explain you other ways of writing your C++. And they were like, oh yeah, that's okay for us. I've learned quite a lot about C++, and I've learned that C++ is actually a nice language. It evolved very interesting. So yeah, where to start? Well, most of the time, it starts with having proper continuous integration in place. And why there is no continuous integration in place? Well, because there is a lack of tests. Well, there is either a lack of tests or the build is just too slow. And then you also have coupling inside the code that makes it very difficult to make small changes to the code, and every change ripples through your code base. So yeah, where do you start then? it's pretty complicated. It's in fact it's context related. Like, what is your situation? So lately, I liked to start setting up the improvement kata to introduce these kinds of change, because these are really large changes that you are going to introduce, and the improvement kata is quite interesting for this. Well, to give vision and to give alignment for the team. Like, look, this is where we want to go. But this is too far away to get there. So this is our vision. How do we get there? And then you start with improvement increments that get you closer to there. And so one improvement increment can be, well, yeah, let's start by adding automated tests. Well, usually from the experience I had is, well, it helps to just start pair programming with these teams and show them, well, what is actually a unit test? How does it look like? How can you write this? And then you look at code, and then you see, like, oh yeah, there's just too much coupling in your code. You need to extract things like, well, one of the things that most of the time misses in the code bases is dependency injection, which in my experience is one of the key practices to actually be able to do unit testing, because it allows you to mock then your dependencies, and, well, you know this.
Yes, I do, but we are mostly, or this conversation is for our audience, of course, so it's useful to repeat these things. And so have you had a situation where the build was very complex and difficult to, like, automate?
Yeah, I had that with actually the C++ code. They were using Qt heavily and depending on Qt heavily. Qt is a C++ library, which was a front-end library. But yeah, as it happens with library, it evolves over time and then it does everything. And it was also used, well, in the back end for lots of stuff. And they had this thing with, yeah, signals, and then you can catch the signal somewhere else at a totally different place of the code, and it was like, yeah, really crazy. And I've always asked, like, yeah, but why are you using this here, and why are you using that? Isn't there a more simpler way to do this? Like a more C++-like way to do this, and yeah. So then, if they needed to do those signals, I suggested, like, but can't you not concentrate this in a single place of your code base, like in one class that does all those things, and that the rest of your code base don't depend on this Qt. And so we moved on.
So do things like Docker or Kubernetes help with these kinds of contexts? Can you Dockerize such an application? Is there a reason to do so? Or?
I rarely suggested that, really. So I like to say of myself, I'm pretty simple, and I like simple solutions. So I'm not looking for complexity. Yeah. So Docker is interesting. Really, I like it. For deployments, because you have a standardized way to deploy. But for development, I don't see much value in using Docker, really, except if you need special infrastructure on your laptop to test something. I get it that you then use Docker, but for pure development, most of the time you don't need it. And regarding Kubernetes, well, I've personally, I never used Kubernetes up until now. No.
All right. So what would be some of the typical steps that you have in a pipeline?
So typically, I would have, so the very first step is what we call the commit stage or the commit build. So it's the first step that is triggered when a change happens in version control. And this step will, will compile your code if you have compilation. So C++, Java. Obviously in Ruby and Python you don't have compilation, and then you can also have I like to have my execution of unit tests in this stage, and static code analysis. So this is my first stage, and at the end of this stage it produces a binary that then can go to the next stage, where typically we would run automated acceptance tests. So these are the tests that execute your application in a deployed setting, so with a front end, with a database, and that executes it as if it is a user that is using it. So here we are really executing scenarios. So typical things that you would express in with Cucumber, for instance, but you can also implement these tests in plain old JUnit like tests. Well, given when, then these kind of things. Once you've done that, during those automated acceptance tests, obviously you need to deploy your application in an acceptance environment. So you have a deployment step before that. Then you have the execution of your tests. If everything goes well, you can then have a manual exploratory testing happening. But you can have a specific step in your deployment pipeline that shows you that. So this artifact is being manually tested. And then when manual testing has been done, the tester can then check the pipeline and say, well, this one is okay, we can move on. And then at the end, you have your deployment into production, which could be manually triggered. So this could be a decision. Typically, this decision should be in the hands of your product manager that decides, like, yeah, now it's good to go into production. You do your deployment in production. You ideally you have some smoke tests that are executed to check that the application is well deployed and that all services that the application needs are actually present. Like, is the database there? Is it functioning? Is my message queue there? Is it functioning? Well, these kind of things. And if everything is okay, you can then just do a flip and say, well, no, this is the new version. The old version can be teared down, and off we go.
That's a good and interesting.
No, this is a simplified version, because then you can start adding more stuff. If performance is really important for you, well, you add a stage with performance tests. If security is really important, well, you add a stage with security tests.
Yes, so it can get more and more complex, but these are kind of fundamental things that you need to do. And only to have these, you first of all, you need, of course, version control, then you need a test suite, then you need an automated build system, and so on and so forth. And now I'll ask the trick question: do you need Jenkins or something like that to actually do this?
So for a deployment pipeline, it helps to have a tool. For continuous integration, you don't need a tool like Jenkins. Continuous integration on its own, you can just, you just need version control, automated build, and that's it, and automated tests, and that's it. And it's just everyone runs the test before committing to the remote mainline. But obviously, for a deployment pipeline, having a tool helps.
So
Jenkins is one. You have plenty of others.
Of course, I'm giving Jenkins as an example because it's very used. But we all know, and we both know actually, that there is often this confusion between practices and tools in software. And we love our tools a lot, and we get very attached to the tools and forget about the practice itself. So the question is, why is Jenkins or something, or a tool like this for a pipeline? What is its usefulness in addition to, let's say, some scripts that would run upon certain events?
Well, the thing I like about it is the fact that they visualize this the process of deploying. So all the steps that you need to go through to get into production, which, well, because you visualize this, you also empower teams, because then they know this process. Because often team members don't know all the steps that need to happen to go into production. And then you also, have a you also make sure that those steps are actually being performed. If you do them manually, you can forget to execute them, for instance. You also have better control on the tools, on the versions of the tools that you use, like also the compiler version, tools that you use to deploy all this stuff. You have a better control over this, and then you can actually start versioning also the whole definition of this deployment pipeline. So you have a better control on this deployment pipeline, because, once you have all this system in place, you become very dependent on this. So if that system fails, you need to be able to recreate it quite fast. I remember in the beginning, so when we started doing continuous delivery, we once had that. Deployment pipeline was not available anymore, it was broken, and all of a sudden you have 6 people that cannot deploy into production. Well, that's a big alarm, because we were deploying every single day, and our users were actually expecting that.
Yeah, so once you show users that it can be done, it's very hard to go back to. So tell me a bit about this pipeline. From my experience, what happens is that you start from something and yet you keep adding things, but then you also need a period of time to kind of stabilize it, because it can still have some weird failures in the first weeks or so. Is that correct? Is this your experience as well?
Yeah, that's my experience as well. So, and an optimization step could be, now I never implemented that, but is to actually also have a staging and a production environment for your deployment pipeline. So having a staging environment where you can actually test this deployment pipeline, and then a real production environment where you don't change things as often, or not before having tested in stage. But to be fair, I haven't implemented it yet, this way of working, but it is an interesting, and I should do that one day.
Yeah, I had the chance to work with staging environments, but usually when we try to convince companies to create staging environments, they realize that they need to invest a lot of money into buying new servers, duplicating licenses for certain products, and so on. So it becomes quite complicated to do that. And I imagine why it can be so hard. All right. And then, so let's say you start with a team like that, and part of this, as we've seen, is the pipeline and the tools and the tests and automating all this stuff. But this is not all. There's also a change in mindset, right? Because suddenly, before then, let's say you were delivering every 6 months a new build, and then being late always because you are testing it for another month or so, and of course. But now suddenly you need to deploy, I don't know, every month or every... what changes in the mindset of developers, or what needs to change in the mindset of the teams together?
So, in my opinion, what is the most important thing is to have a quality focus and a focus on the done metaphor from XP. So it's not only development done, but it also needs to be tested. It needs to go successfully through automated testing. It needs to go successfully through manual exploratory testing, and then you need to be able to deploy it, and etc. etc. You also need to take this mindset of taking the whole operations side into account. Like, yes, but going into production means we need to have proper logging. We need to be able to deploy it easily. We need to be able to configure it easily. We need to be able to do this via scripting, not via manual modifications of manual steps. So it's really an attitude like, well, in the end, we should be able to manage this thing in production. And we want to have as little failures as possible in production because, well, we have to fix those failures. And once a team is responsible for this production environment, well, interesting things are happening because they are all of a sudden they are looking at these things and they are fixing those non-functional requirements.
So, but there are certainly differences. So if we think about some examples, like, Amazon. For Amazon, one last statistics I learned is that roughly every 10 seconds a new version is in production, which is for companies that are releasing yearly or every 6 months, it sounds like impossible. It sounds and we have other examples like this of companies delivering at least every day a new version of a product. And you hear these statistics, and then as a company or as a team that has been delivering yearly, what do you need to do together if it's worth it? Because sometimes it's not worth it.
So yeah. So now those statistics, to be fair, it's also a bit of a vanity metric. So not all companies need to deploy every single hour. For many organizations, deploying every 2 weeks is good enough. So it depends on their business needs and on their market demand, how many times you need to deploy. So it starts with identifying that. So what do our users are expecting from us? Once you know that, well, you can work towards that. So in 2018, I was asked to help a Belgian federal agency to go from deploying every 6 months to deploying every 2 weeks. And because they really had a demand to deploy every 2 weeks. So what we did is, well, it's there that I've started setting up this improvement kata. And this is what we've done. So we've set up an improvement kata. We've defined this vision. Look, your vision is every 2 weeks. Now, how do we get there? What is the current situation? How does our process look like today? So we did value stream mapping. And we discovered that they had 2 value streams, actually. They had a feature value stream for deploying features that took 6 months, and they had a fixed value stream that was happening, guess what, every 2 weeks to actually deploy fixes in production. And from time to time, there was a feature that was deployed in this fixed value stream. And then it happened more often and more often. So, well, I've said to them, well, look, you're doing it. It's just that you're not doing it in a controlled way, and then you're hiding it. So what we are going to do is make this fixed value stream more robust, more visible, so that it can function as your feature value stream. And so we analyzed the fixed value stream, and then we discovered that the automated test was really, really unstable, like failing 70% of their time. So, well, look, here's what we need to work on. We're going to improve the stability of your tests. So why are they failing? And then there was like, oh yeah, tests were in a different version control repository than production code. So there was a desynchronization between production code and test code. Okay, so that put all the tests together in the production code. Oh yeah, we cannot do that because the size of the test repository is too big. All right, so first time I've heard that. Okay, let's reduce the size of the of the test repository. Well, and then they started working on this. Notably, one of the reasons was they were using too big test cases, and they were using huge XML files that described test data. So we started working on reducing the test data, making it more precise, more simple, working on specific use cases, not trying to test everything in one test. All the problems were dependencies on third-party services. Yeah, obviously, when the third-party service is not up, well, test is failing. How can we fix that? Oh, well, we can mock the third-party service. Yep, let's implement that, and etc., etc. And we moved on. And in the end, they managed to release every 2 weeks.
Yeah, so you mentioned the improvement kata a couple of times, and it would be interesting to talk a bit about it, what it is, and how are you doing it. So
the improvement kata is a framework to introduce change at scale in an organization and to measure the adoption of the change. It's been described by Mike Rotter in his book, the Toyota Katas, and it's one of the Toyota Katas. So it consists of 4 steps. And so your first step is you define a direction. So this is your vision, the goal you want to achieve in a far, far future. And once you have this goal, you start by analyzing your current situation. How does your process look like? Which data do you have? And then you look at how can we get to this vision, and you get to this vision in improvement iterations. And for each improvement iteration, you define what he calls a target condition. It's like an acceptance criteria. So we've achieved that improvement if that criteria is fulfilled, and we want to achieve that in that amount of time. So we set a fixed date, like in 2 weeks or in a month. And then you start executing lots of experiments with the PDCA cycle. So plan, do, check, act. So you plan an experiment with an expected outcome. You execute the experiment, you collect the results, you compare the results with the expected outcome. If it was successful, while you incorporate the experiment in your baseline. If it wasn't successful, well, you discard the experiment and you try something else. And so you move on. It's in fact, it's applying the scientific thinking. You formulate an hypothesis, and then you try to either falsify the hypothesis or crucify or something like that.
Yeah, it sounds very. I see a lot of connection with the Kinevin framework and thinking model.
Yeah, so it's for the wait. So you have the complex. It's complex or it's complicated.
In the complex, it's in the complex domain.
In the complex area. Well, it's very useful in there.
Yeah, and I also see, of course, coming from Toyota, it's about lean. Fundamentally, is the same thing. You also mentioned value stream mapping, which is one of the lean practices that's really helpful, and you use that to analyze the current process, right?
Yeah. So, and here, well, it's not the whole value stream that is analyzed. It's really what we in continuous delivery like to call the technology value stream. So everything that happens from committing code into version control until getting that code into production, and then releasing it to the user. And so it's only a small part of the whole value stream.
Yes, and then you are trying to reduce basically the cycle time of this.
Yeah.
But now the question is it always worth reducing the cycle time for things like this, or is there a limit?
Well, that's a difficult one. It depends on your. In fact, it depends on your market demand. So, if your market is not demanding you to deploy more often, well, there's no reason to reduce it. Now, often it can be useful for you as a team to just reduce it because it allows you to fix problems faster in production. So you can reduce your mean time to recover, which is far more important than your mean time between failure.
Yeah, because this is often a conversation that we have with teams that, we cannot deliver to production, let's say, for various reasons. We can only deliver like every 3 months or every 6 months to production. And then is it worth having a system that deploys to, let's say, a staging environment every 2 weeks? And the answer would be that yes, if it helps you reduce the errors.
Yeah. So okay, you can only deploy every 3 months in production. Wow. But you have a staging environment where you can deploy every 2 weeks. Well, look, every 2 weeks you get feedback on this deployment in staging. It's not your production. It's not as good as production, but at least you get feedback. Hopefully the staging environment resembles production. Now, this is a great question mark, but at least you get some feedback. It's better than waiting 3 months for that feedback.
Yeah, and the alternative would be to deploy to production, but while turning features off with things like feature toggles. Have you seen code with feature toggles? Because to me, I haven't actually seen some, but I imagine it's full of if statements.
Yeah, so it can go horribly wrong. So it's always like, feature toggles. So feature toggles is very interesting to have, and it's a big enabler for operatability. So if something goes wrong in production, it allows you to turn off a feature. You can do graceful degradation. It's the thing that Netflix implements. So all of a sudden you have your continue watching that disappears in your user interface. Well, probably there is a problem with the continue watching little microservice at Netflix, and so they just turned this thing off in the user interface. So they managed to do graceful degradation, keeping the core functionality working, and then disabling everything that is not needed. But so second thing is also, well, you can also deploy functionality in production when it's not yet finished, which is quite interesting because you can start getting feedback on this code, and it's still not finished, and user is not impacted by that. On the other hand, if you don't manage those feature toggles, well, it can go horribly wrong. So feature toggle, it's like work in progress. You want to limit them. You want to limit the number of active toggles. And whenever a toggle is not needed anymore, you just remove it from the code base immediately. And also, well, the way you implement them, there are various ways to implement them. Yeah, classic one is just using the if else statement. Sometimes can be good enough. Otherwise, well, you can go with factories, or well, moving that decision into something that is responsible to do that decision, or using a strategy pattern for this kind of things.
Yeah, there's still conditionals in different ways. Fundamentally,
it's still conditionals, but you try to manage them in a more easier way.
Right. So the advice would be, if you can, it's probably better to use feature toggles, because at least you deploy to production, you get some real feedback, you don't affect your users with this, but at the same time try to keep it as a minimum, because as everything.
And you also need to test those toggles. So you also need to run your automated tests against the toggle on and off, well, to see if it behaves correctly.
Of course, it's production code, so it needs to be tested. So there's a general thing that happens here, other than the general principle of reducing cycle time as much as you can, even if it's not obvious why you would do that sometimes. The other one would be what you mentioned before, to minimize work in progress. Right, and these are lean principles, but these fit very well with continuous delivery, it seems.
Yeah, so the continuous delivery is actually introducing lean in software engineering, because while we have this concept of flow, so we want to move code, like really move continuously from version control to production. So we want to limit the batch sizes. We want to avoid piling up code that hasn't been deployed into production. So that is the idea behind it.
Okay. So you have talked about one thing in the past, which is about feature branches and how they affect this work in progress. And can you explain that? I know we had a bit of an argument over Twitter for that, which was very interesting because we clarified what we mean by this. But it's interesting to talk about why you think that feature branches are evil.
So there are various reasons. So if we go back to the lean principles, one of the things that happens with feature branches is that you are actually piling up code in branches, and that this code doesn't get into production as long as that branch is not merged into mainline. And so you don't get feedback about this. A thing I like to say, but this is already getting far ahead, it's more like an economic principle. It's because you are piling up code in your branches, you are creating an inventory. Now in software, inventory is very invisible, where in manufacturing, well, most of the time, inventory is really in your face. You see it everywhere. So here we are creating some sort of inventory. And in manufacturing, well, we say, well, look, inventory is money. and it's money that is stuck in the system. It's there, you've invested money to create this inventory, but it doesn't generate revenue for the organization. It's only going to generate revenue once this inventory is turned into valuable products for your customers. And in our situation, it is well, it's going to generate revenue once you merge into mainline and the code gets deployed into production and that the user can actually use this code. Now, on the other, where it's other problems that arise is that, well, you don't get feedback as long as the code is on the branch. Now you could argue, yeah, but we can run our automated builds against the branch, and yes, this is a very good thing to have automated builds against your branches, but still, it doesn't give you information if this code will integrate well with the code that is sitting in all the other parallel branches. You don't get that information. It's only the minute that you integrate that you will get that information. Now, the interesting part was that conversation we had, the two of us, on Twitter about the evilness. And, well, it's you that made me see that the actual evilness is behind the use of the feature branches, which is, well, the real reasons teams are using them. And we came to the conclusion, well, the real reason was like, yeah, but, well, first, teams are lacking incremental software development skills, or the teams have a code base that is too coupled, or they are lacking automated tests, or the test execution is just taking too long. And therefore, most of the time, teams are falling back on branches because, well, it solves those symptoms, but it doesn't, well, it solves those problems, but it doesn't really solve the root cause.
Yes, and the thing is that I've used before things like Subversion, and I think it was Visual SourceSafe, which were very, very poor software code kind of source control systems, because so branching in Subversion would take a lot of time. Actually, Git, when Git came up, one of the heavy improvements was that the cost for a new branch is 0. It's very fast to do a new branch. While in Subversion, you would have to wait a long time for a branch to happen. So because of that, we were actually rarely doing branches. But at the same time, what would happen was the other thing, that people would not commit very, very much on production. And this was good for, well, this was possible in Subversion because you still had your separate line. It was the developer line, it was yours. You were not blocking anybody else. But there is, it was even worse with Visual SourceSafe, because with Visual SourceSafe you would block files for everybody else. So, so that was.
I remember that.
So that was even funnier when developers were living in holidays and leaving files locked, and then you have to go to the administrator and unlock the files for you so that you could make changes. And then it was a mess when the developer would come back and try to figure out what was going on there. And that's why, seeing all these experiences, there's one thing that stays to me: the developers will find a way, unless they have the kind of the mindset and the system around them that goes in the right direction. So, for example, I see many people complaining about it's so hard to do merges in Git. No, it's not hard. What is hard is when you have a lot of branches that are long-lived and then you try to merge them. That is hard.
Yeah.
If you merge every few hours, if you merge every day, it's not that hard. How much can people actually add them?
Yeah.
So these are all symptoms to me of a different problem, and the problem is that we don't think in small enough batches, usually. And
yeah,
that's...
so indeed, so it requires quite some thinking while you want to do refactoring, or if you want to do this big change, well, to actually split this up in small increments that don't break your application, and this is where the hard thinking is required. And sometimes I still make errors in that area, because, well, I've done a change that, oh no, that change I shouldn't have done it at that moment. I should first have done another change. Oh yeah, but yeah, that's the challenge, as you say. And if you're able to do that, yeah, then, well, the merging isn't that problematic.
And I agree that, so you could do trunk-based development, which means everybody, whenever they are committing, they are pushing to trunk. That's perfect. But you also need to have a second rule, which says you don't keep the code on your computer for too long, because you have a branch on your developer machine. It's not a named branch, so but it is a branch.
Yeah, cloning the repo is a branch. So as long as you don't push, well, the rest of the team doesn't know the code you have.
Yeah, and so I like this idea of inventory, as you put it, and as it's described in Lean. And I think Mary Poppendick did a list of types of inventory in software development, and part of it is, of course, code that is around there and not not actually pushed. By the way, I have a nightmare story about merging, which is I have worked with a team that had, like, for the previous release, they did a branch, and it was 1 year later, and they tried to merge it, and you can guess what happened then.
Oh yeah, gosh.
So,
how many weeks did they spend merging?
They tried, and then they just gave up and said, no, we will leave it as it is. But I think they tried for about 2 weeks to make the merge, and then realized that there's no chance of actually doing anything with that. Yeah. So you see, there are a lot of weird ways to do things. And this idea about small batching and thinking incrementally actually relates back to what you're talking with building mechanical devices. You're going in small increments. You're trying to. It's kind of the same thinking, right? It's not.
Yeah, different. It's the same thinking. I'm going to try this little thing. Does it work? Yes, it works. Okay, I can try this other little thing. Yeah, it works. Okay, I can move on. Oh, this one didn't work. Okay, we revert, we try something else.
Yeah, and then the challenge is to try to make it into small enough steps so that revert is not as painful and...
Yeah, exactly.
Right. So I think this has been very interesting, and I have another question for you related to new programmers, junior programmers. But before that, is there anything that you'd like to tell our audience that we haven't discussed about until now?
A pattern I like to mention a lot lately is expand contract. It's one of those key patterns that helps you a lot in doing small increments. So the expand contract is actually used in many places. So while the blue-green deployment is an example of expand contract, but also database schema migrations is full of expand contract. So you expand, you add something to the code, like if you want to change signature of a method that is used at 100 places in your code base. So if you change a signature, well, you will have compilation errors at 100 places in your code base. Changing those 100 places will take you far too long. So what you do is, well, you duplicate the method, change the signature, and then you start gradually changing the method calls at those 100 places, but each time your code is still compiling because you still have old signature. So you are in this expand space. Once you've changed all your at all places, well, you can then contract. That is, you can remove the old signature. And at every step when you did that, well, you can just deploy your code in production.
Yeah. And I see this application as well when you try to, let's say, move a function from a class to another class, or database migration, even interfaces. Sometimes you can you can add elements in user interface, perhaps with a feature toggle, and then remove the old elements.
And so lately, I'm now, so the past year and a half, I'm most of my time on infrastructure and working with infrastructure code. And there, well, I need to use this pattern quite often because, you want, in AWS, you have some of those resources. You've named the resource, changing the name it's just not possible. If you want to change the name, you need to tear down the resource and create a new resource. But the resource is being used by other things, so you cannot tear down the resource like that. So what you need to do is, okay, I'm going to create a new resource with the correct name, have all the client components use that new resource, and then I can tear down the old resource.
Yeah, AWS could use a tool for refactoring. I agree. I have seen some of these problems as well. Yeah. Okay, so before we end, one question related to junior or new programmers. Knowing what you know now, what would be some advice that you would give to somebody who is just starting or new in the field of software development, perhaps is interested in software engineering as an idea, or wants to do a better job?
So the thing I've missed when stepping into software engineering, well, the thing I'm a bit disappointed in is when I stepped in software engineering, XP was just introduced. So we're speaking 2002. Extreme programming came out late 90s, and I completely missed that. I really completely missed that. It took me another 10 years to actually get into extreme programming. So the advice I would give to juniors is find an organization that actually applies extreme programming, and where they do proper coaching, like they sit next to you, do pair programming or more programming, show you how to properly implement code. Just program. So I've learned that all on myself, and then the trigger was going to code retreats, which Adi was facilitating in Belgium at that time. That helped me a lot, I have to say. But having an organization that already does this makes really a difference. Each time I've had a junior, I took the time, like for 6 months, sitting next to that person, showing, look, you can implement this like that and like that and like that. And they were like, why don't we learn that at school? Well, look, school isn't there to learn you to program. School is there to learn you to think. Now you're learning to program.
All right. Actually, there's one thing that I wanted to tell you, because I think this is very important for other people as well. You mentioned in some interviews and blog posts that you felt a bit weird coming to software development without having the proper education as a software developer. Can you tell a bit, because I think there's a lot of discussion sometimes of people who come from outside software development that they are no real programmers or whatever, and I think it's just stupid.
So for a long time, like career, I felt the the need to at least follow, like we have here in Belgium this concept of open university, so you can just go to follow courses, you pay for this, but you don't need to pass the exams. And I felt the need, like I need to follow open university for computer science, because I don't have compiler theory, I don't have state machines, and I'm lacking this knowledge. Up until, well, the team where we adopted continuous delivery, someone told me who had a computer science degree, and said to me, like, look, Thierry, you don't need that, you know enough. Okay, fair enough.
Yes, and I'd like to repeat this. I have a formal education as a software engineer, but I never thought of excluding people who don't have this type of education. In fact, I know some extremely good programmers who don't have a formal education in software engineering, and they are really, really good.
Well, I know also some. I know some software engineers that have absolutely no education and that are far better than others that do have education.
Yeah.
And Jess Humble, for instance, has a degree in philosophy, and he's a super interesting person and a super good engineer.
Yeah. So to the audience, if you don't have a formal degree in software engineering, somebody is giving you a hard time about this, tell them it's stupid. I said it's stupid. And don't listen to them. All right. So thank you, Thierry, very much. Where can people find you?
So, on Twitter, I'm T de Pauw, so TDPAUW, and I have a website, but I don't write a lot of articles. It's called Thinking Labs IO, and that's it. Yeah.
Thank you, Thierry. This has been very interesting, and I think it will be very useful for our audience as well. Good luck to you in everything you're doing. And for our audience, thanks a lot for listening to this talk, for watching this talk, this conversation. I hope it was very useful. If you find useful things here, it's great if you can share it. We have to give our dues to the algorithm, so like and subscribe to this channel if you enjoy it. And until next time, remember to think, design, and work smart.